All right, thank you. We'll move on to our next talk, which is Blake Cothron talking about diseases in Pawpaw. The big one is full. Thank you.
All right, I hope everybody's doing all right today. I'm the owner of Peaceful Heritage Nursery, which is just about 50 minutes from here. And I'm the author of Pawpaw, the Complete Growing and Marketing Guide. And you can pick up this book on Amazon and Barnes & Noble in either paper or ebook copy. And please purchase a new copy as that supports my work. So we are going to talk about trees today. And I want to make the point that AI was not utilized in any aspect of this. And I think that using AI for such purposes will decimate humanity's intellectual and creative capacities. And so the presentation is about the most important diseases of pawpaw. I wanted to talk about more diseases, but due to the time restraints, I've got to shrink it down just to the top 3 most important ones, in my opinion. And we'll be exploring the potential impacts, some possible organic controls, and management strategies. So there's probably going to be a lot of questions in your mind about how do I manage, or what spray do I use, or can I use this spray? And I will say that there's just not a lot known right now about the controls of these diseases. So we're just going to, a lot of it is just hypothetical at this point. So as pawpaw production in any significant amount is still in its infancy, there's simply a lot we don't know. All right, let's go ahead and dive in. So any discussion on pawpaw diseases typically starts with the most noticeable disease, and that's Phylosticta. According to Wikipedia, there's a total of 3,213 species of Phylosticta. And as it's referred to in pawpaw literature, it's a fungal disease that displays obvious visual symptoms on foliage later on the fruit. It typically begins to appear in June or July, and this is what you're typically going to see. You'll note that those are brown lesions that lack any substantial halo or ring of color that surrounds the lesion. So that's important in identification. The margins of the infected area are black and necrotic. So you can note here the characteristic brown and black blotching, and it appears like classic fungal mycelial growth across the skin of the fruit, that sort of webbing look. The damaged areas often become thick and scab-like. Minor infections, or perhaps on resistant cultivars, can exhibit minor symptoms that don't damage the pulp always. They'll just have black spots, but the pulp will be okay. That's more of a superficial infection, and it remains completely edible. And a lot of buyers may not mind the little black spots, especially if the pulp is okay. Just kind of like black spots on a banana is what it looks like. But this is a severe infection, and at this point the disease has consumed the skin and prevented cell growth and expansion of it. As the unaffected portion of the fruit continues to grow, so the fruit continues to expand, but the necrotic areas do not. This leads to a cracking open of the skin at the necrotic areas. This creates a leathery, inedible pulp texture that ruins the fruit, and so it's unusable and unsellable. So understandably, Phylosticta is potentially a substantial economic importance in the production of pawpaw. So what are the factors that lead to it? Warm, moist environments. So regions with ongoing high humidity and high rainfall will likely experience higher infection rates. Being that pawpaw's native range and most favorable conditions experience warm, humid summers, Phylosticta will likely show up at some point. How does it spread? So Phylosticta spreads via spores. At the advanced stage, in the infection lifespan, spores are released. Sydnia, fungal fruiting structures, are produced within the leaf spot, often in a ring pattern, and these can be seen as black dots within the infected area. It would likely be the case that these spores are released late in the growing season, where they spread and overwinter on dormant pawpaw tissue. So as is often the case, the fallen leaves and infected fruit are likely potent sources of Phylosticta inoculum. So cleaning up fallen leaves from the infected trees can increase origin hygiene and lowers inoculum levels. And on scale, you could do something like mowing the leaves into smaller bits, which would decompose rapidly, just like with a lawnmower sort of thing. Spraying compost tea could inoculate the leaf litter with beneficial bacteria and break it down faster. So the idea is to get rid of the sources of inoculum as fast as you can. So hygiene is always an effective starting point of management in the case of fungus and diseases. So some cultivars are claimed to be resistant to Phyllosticta. I would posit that the situation is more likely to be that some cultivars are highly susceptible while others have average susceptibility. In my orchard, I've seen varieties that are supposedly resistant show symptoms of the disease after time. So true Phyllosticta resistance seems to be unusual. NC1 does seem to show some resistance, and it would be a worthwhile trait to select for in breeding. There are limited options for USDA-approved chemical sprays for the use of growing on pawpaws. Pawpaws remain a gray zone in that regard. There has been some progress made in that in the last few years. But certainly we have practical options for management of Phyllosticta and other foliage diseases without toxic synthetic chemical use. So if any of you all are organic growers and you've never heard of Surround or not familiar with it, you should really research it. Absolutely amazing product. It is made of kaolin clay. So it's the food-grade kaolin clay. It's the same product that's put into toothpaste and other products that are food-safe products. So it's completely non-toxic. It's OMRI listed, and we'll show you what that does here in a moment. You could also check out copper, like the brand Coside. Micronized sulfur could also be used for the control of fungus diseases. And yeah, newer option is Surround, okay? And so Surround forms what's called a particle film. And it's a new organic breakthrough in pest control and disease control. Okay, so this is what trees look like when they've been sprayed with Surround. They look almost like they were spray painted white. So the film's porous, so it allows gas exchange and transpiration. However, under microscope, it can be seen that the kaolin clay is composed of tiny nanoparticles. So they're very irritating to insects, and they also make a very inhospitable alkaline surface that fungal spores have a lot of difficulty taking root in, so to speak. This is a close-up of a leaf sprayed with Surround. So it can also help prevent sunburn because the white color reflects sunlight. So when pawpaws are being grown in less hospitable environments like sunnier, warmer locations, like maybe even outside of the U.S. or places like Texas or California, this could be a game changer to help your trees really thrive. And so it's our duty as 21st century growers to use effective non-toxic controls as well as natural fertilizers that don't pollute local waterways, soil, or people. So the conclusion is that Phyllosticta is an important endemic disease of pawpaw and can have economic impacts. Choose pawpaws that are not highly susceptible and practice good orchard hygiene, and if needed, use organic antifungal controls. I have heard by some people anecdotally that they don't experience Phyllosticta problems in Europe, where it's that species that affects pawpaw is supposedly not an endemic. Okay, black spot. Black spot is a bit of a challenging, hard to understand disease, and we'll look at it here. So this harmful fungal disease has recently been identified thanks to the help of Ron Powell. The disease appears in very wet and rainy seasons. The signs of the disease are blotchy black spots visible on both sides of the leaves. The undersides of the leaves will show black spots with a patchwork-like appearance. The leaves will gradually turn yellow, droop, and often prematurely drop in August or September, thus exposing the fruit to sun scald. So the less foliage you have on your trees, the more problems you're going to have with the fruit potentially getting sunburned. This is what a tree with black spot looks like. So it appears to lower the tree vigor if it continues year in and year out. It does not appear to infect the fruit, but can negatively affect it indirectly through loss of foliage and shade. So no resistant cultivars have been identified yet. It can be differentiated from Phyllosticta by observing the foliar lesions. So note the bright yellow halos of black spots. So you might remember the Phyllosticta picture. They were just little black spots with kind of grayish necrotic area with a little black circle around it. Black spot seems to have these bright yellow halos. So there's questions that remain. What are the long-term effects of black spot? How does it impact fruit production? Is it systemic? It's believed that ongoing and sustained black spot infection can weaken the trees enough to kill them. This makes it a serious disease of pawpaw. Being that black spot is a diplocarbon species, it's fungal, just like Phyllosticta. Wet, humid conditions and poor airflow will likely favor its proliferation. So control would be spring and summer applications of organic antifungals such as neem oil, micronized sulfur, liquid copper, Surround WP would likely prove effective. I will say there is another theory you could say in organic production, and that is that if you can colonize the foliage with a beneficial bacteria, then it prevents a harmful bacteria from taking hold, similar to like we were talking about the gut biome. If your gut biome is healthy, it's a lot less likely that a harmful pathogen can take root and proliferate. So the answer to that is, or one way that that's done is compost tea. So compost tea does not need to be aerated. It just needs to be leached out into water, very carefully filtered, and sprayed, and foliar applied to trees. And I've seen good success with using it on apples in the past. All right, so the most important disease we're going to talk about today is blue stem disease, or BSD. It's sometimes also referred to as vascular wilt. Okay, so it's a very serious disease that is unfortunately still not well understood, at least in the case of pawpaws. And here are a few basic facts. So also known as vascular wilt or vascular decline, but currently referred to as BSD. It affects pawpaws of any age. The direct means of infection remain unknown. It's fatal to pawpaw trees, leading to gradual decline over a number of seasons and then eventual tree demise. So what you're seeing here is the inner bark that's been exposed to BSD, and I basically ripped the bark off of the young tree, and that's what it looks like underneath. So instead of it being nice and bright green and clean and bright, it looks terrible. Blue and black staining. So the symptoms include diminished foliage size, yellowing of leaves, fruit can also appear yellow, cracking and small fissures on trunks, branches, and larger twigs. We'll see some photos of that here in a bit. The blue-black staining under the bark and on both the xylem and cambium tissues. Rapid tree decline and demise. So infected trees die within a few seasons of infection, or at least within a few seasons of appearance of visible symptoms. Okay, so this is a subtle difference here, but hopefully you can see it. There's a healthy pawpaw tree on the left, and there's a BSD-infected pawpaw on the right. So you'll notice that the one on the left, the leaves are bigger, they're darker green. This one, you can see the leaves look slender, smaller, more yellow. So it's a healthy pawpaw leaf on the left, BSD-infected pawpaw leaf on the right. So that should make it a little bit more obvious there. So these are the bark fissures and cracking due to BSD. So you can see there's this cracking here, right in there. You can see the cracking, and you can see the cracking here. And the cracking follows the flow of sap through the cambium tissue. And this is the blue staining of tissue. You can see when the bark is pulled back, you can see the staining on it. It's very, very obvious. So what are the physiological effects of BSD? So BSD compromises the vascular system. The BSD-affected vascular system becomes less effective at transporting nutrients and water to the branches, trunks, and leaves. So the diminished nutrient and water supply leads to the symptoms just mentioned, including smaller leaves, yellowing of leaves, diminished fruit yields, because the tree's pumping less nutrients into the branches and leaves, so therefore the leaves are getting smaller, the yields are going down. The wilting of the foliage in hot weather is also a characteristic of BSD-infected trees, again, due to the diminished ability of the BSD-affected vascular system to deliver water to the foliage. BSD-infected trees usually go into a marked decline after a few years. How long this decline takes is unknown exactly, but it appears that the trees are generally dead or severely compromised within 3 to 5 years of infection. They will display obvious symptoms like yellowing of foliage and bark fissures. Younger infected trees likely decline faster. Older trees may take longer. It can be observed on trees of all ages, including 2 to 3 year old seedlings. And the reality is there's no known cure for BSD, and once infected, the tree is likely to go into decline. It's also unknown at this time what causes BSD in pawpaws. Potentially similar blue staining diseases affect conifers caused by species of fungi. However, BSD in pawpaws is not believed to be caused by fungi. Several cultures done on BSD-infected pawpaw tissue were found to contain fluorescent pseudomonads, a type of bacteria commonly causing BSD in other tree species. And this was taken from the Oregon Pawpaw Regional Variety Trial. Okay, so what is a pseudomonad? Okay, according to Webster, any of a genus Pseudomonas of gram-negative rod-shaped motile bacteria, including some that produce a greenish fluorescent water-soluble pigment and some that are saprophytes or plant or animal pathogens. So the pseudomonad that causes BSD would be a saprophytic species, and fluorescent bioluminescent, meaning it glows. So BSD is a bacterial infection. So how can we manage it in our pawpaw orchards? Prevention is crucial as there's no cure or chemical organic control known at this time. Hygiene is always a major part of any sort of control measures with disease. So you want to clean your grafting tools and pruning tools with alcohol frequently. Remove any trees showing symptoms and burn or remove from the orchard. Never leave them stacked up in a pile. That's a great way to attract ambrosia beetles. Remove root systems also if able. The root systems could contain the bacteria also. Destroy any nursery trees showing symptoms. Do not reuse potting soil. And sterilize pots with phi sand, which is what you see here. It's a greenhouse sterilizer product that works much more effectively than bleach. You want to scout your orchard regularly and flag any trees displaying yellowing foliage or smaller than normal leaves. Next, inspect the flag trees for bark fissures or other visible symptoms of BSD. Bark fissures will be present on the trunk or branches of infected orchard trees. Okay, so the bark fissures are the big red flag of potential BSD. So you'll note the small cracks parallel with the phloocambium tissue. Infected trees showing bark fissuring must be removed and destroyed. And avoid saving or distributing scion wood from BSD-infected trees as it could possibly contain BSD bacteria. Exercise caution where you source scion material from. Always sterilize grafting tools as you graft. And I have a very strong suspicion that BSD is being spread around via infected scion wood. Okay, so don't confuse southwest injury or winter sun damage with BSD. So southwest injury is a physiological disease, or not exactly disease, but a physiological condition where the winter sun warms up the south or southwest side of the tree. Sap starts to flow on a warm day. It rapidly freezes and cools at night and splits the bark open because it's full of sap, and it freezes and it expands and breaks. Southwest injury can lead to bark cracking and can lead to reduced foliage size as well as tree decline, but it's a physiological disorder that's completely preventable. Southwest injury creates long, smooth, open cracks. BSD forms shorter, more jagged-looking cracks in small groupings. Okay, so this is BSD on the left, southwest injury on the right, and sapsucker damage on the far right. So sapsuckers are a native species of woodpecker, and they peck into trees to get the sweet sap, and they really enjoy feeding on pawpaw trees, and that's what their damage looks like. It looks like little rows, like someone took a drill and went zip, 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 zip in lines across the tree. So all those could be confused for BSD and vice versa. This is severe southwest injury on the tree on the left, and then that's a painted tree, and you paint them with 50% indoor latex paint, white paint, latex paint, watered down 50% with water. You paint that on the trees to prevent southwest injury. So it's very important to do to your trees if you're not already. Okay, so the crucial question is, how does BSD infection spread? Okay, so Pseudomonas responsible for BSD can be found in the seeds of a diversity of plant species, including undamaged and unbroken seeds. So it can be found in seeds. We don't know if it can be found in pawpaw seeds, but it can be present in seeds. It can also likely be spread via scion wood from BSD-infected trees. Similarly, a BSD-infected rootstock will infect a graft. BSD can be found in non-grafted as well as grafted trees. However, grafting could certainly be a point of infection. And can Pseudomonas responsible for BSD infect pawpaws via the root system? Okay, this leads to the questions: what factors lead to the proliferation of BSD in the soil? And can infection spread through an entire orchard via diseased roots? How contagious is it? Do any factors make pawpaws more susceptible? Tree stress, damage to root systems, lack of nutrients, etc. So moving forward, as of right now, there's little understanding of any real management of BSD. Stay vigilant and scout for visible symptoms. Keep orchards and nurseries clean and implement strong hygiene. Rapidly remove any trees showing the infection and remove them off site or burn. So again, my book is Pawpaw is a Complete Growing and Marketing Guide, and you can purchase that online. Does anybody have any questions?
Yeah, hey Blake, I'm Susan, and I'm also an organic grower, and I really appreciate the fact that you were talking about the surround, and I have never used that. Two questions about it. Do you spray it under the leaves as well, and will it deter the zebra swallowtail caterpillar from eating the pawpaw leaf?
Yeah, so I would say generally with foliage spraying, it is a good idea to get the undersides of the leaves. Now, with pawpaw, it's a little hard because, they droop. And typically, I think a lot of times, things that affect the foliage seem to affect the top of the foliage. Like the eggs are usually laid on the surface of it, and, spores typically would most likely land on the surface of it. I'm not 100% sure if it would keep ZSB at bay, but I think that it would. Now, I know that we like ZSB butterflies, but the reality is that when you're starting a young orchard or you have a nursery, they can cause a lot of damage. I have found that spraying pyganic and neem will effectively kill or keep the larva off temporarily. And what I do in our nursery is I hand pick off as many caterpillars as I can find. I put them on older established trees. We have a bountiful population of them on our land now. But in the nursery, when the trees are young, I do spray pyganic and neem to keep off any number of insects, including ZSB. But I think surround would be effective, I think.
My question is, will BSD damaged tissues fluoresce under UV light?
I'm sorry, I couldn't hear you.
Will BSD damaged tissues fluoresce under a UV light?
Oh, like would it glow?
Mm-hmm.
I guess theoretically maybe there could be some glowing because of the bacteria, but there may, that maybe you'd have to look at it under a microscope. So I doubt that it just under UV light you could just see it, but I suppose it's possible at the naked eye, But they do glow.
So we have BSD, let's say, Pseudomonas problem sometimes with orchids. And it's kind of a big issue, but the problem starts already with young plants. So it's, like you said, very important that the cyan wood is healthy. But how do we solve the problem? So hygiene is the most important. But then you can spread it, especially in Europe, Netherlands, they have to reuse the water. So it's spread it with the water. So if you have contaminate your water source, you can spread it with irrigation as well. So then they sterilize the water. A lot of growers do it with chlorine. We do it with copper electrolysis. So with electrolysis, you add copper ions into the water. So we see the effect on it. So it is also helping a little bit with adding microorganisms. So we use EM, and also it's helping a little bit, like you said, compost tea. Mm-hmm. But that's difficult to measure.
Does it seem like it comes in through the root system?
Actually, it comes on the leaves, and then it spreads all over. So you see it is affecting, and all the plants die. And if it's attached to another plant, it also spreads. Or already if you irrigate, it also with drops can spread around. And also with insects. If you have, but mostly we grow, in greenhouses you don't have problem with it, but if you have some insects which suck, like spider mites, then it can spread those diseases as well.
Do you have any updates on BSD? Do you have any updates on BSD?
Question?